Welcome to another podcast. In this episode, we're going to be taking a look at trig identities designed to get you up to speed on some of the trigonometric integrals and substitutions that we're going to encounter this week. This should be a review for most of you that are in this course, but it does not hurt at all to take a look at some of the things from trig. We're going to start off by briefly defining what the trig functions are and where they come from. To do that, I'm going to need to draw a couple of triangles here. So this first triangle that I want to draw is going to represent how the trig functions are related to points on the circle. And the second triangle that I want to draw is going to look at a circle of arbitrary radius. Alright, so looking at this first one, we assume we have an angle theta. These are right triangles. And the point here at the center is the center of the graph, which would be at 0, 0. And the horizontal distance is x, the vertical distance is y. And we are on a circle of radius 1. And so what we are trying to describe is all points x, y that lie on a circle of radius 1. And what you should know, or at least what you should remember, is that those are exactly cosine and sine. And so cosine of theta is defined as being the x value, and the y coordinate on the circle is defined as being sine of theta. Now, if we expand this to not only being a circle of radius 1, but potentially a circle of arbitrary radius, radius r, then we can define the points on the circle similarly by doing the following. X is r cosine theta. This is also the key, by the way, to defining polar coordinates, which is something that we will do later on this semester in calculus. And since this is the case, one of the things that we often do is we'll divide r over so that we have cosine of theta equals x over r. And if you look at x, x is the adjacent angle, that's usually what we call it, or the adjacent side, excuse me, to the angle theta. And then r we call the hypotenuse. So one of the standard ratios that you're supposed to remember from trig is that cosine is adjacent over hypotenuse for any given right triangle. Similarly, the y value here is denoted as r sine theta, and so I can rearrange things within that identity as well to come up with the familiar y is the opposite side from the angle theta over the hypotenuse r. And then the final one that we want to look at here is what happens when you look at the ratio of y with x. And the reason that the ratio of y with x is important is that's designated as the slope. And so the slope of the line is literally nothing more than the ratio of these two terms, which is sine theta over cosine theta. And notice that r doesn't even appear in this description at all. What this entails is y over x, we give a new name, and we call it tangent of theta. And because y and x are both cosine and sine, then tangent of theta is oftentimes defined as sine of theta over cosine theta, or just simply, since y over x is the opposite and x is the adjacent, a lot of times we'll just say opposite over adjacent as well. So there's a lot of things going on with tangent, but the main thing I want you to take away from that is that tangent represents the slope of the line segment there, and has very little to do with the radius. The radius is not going to affect the slope. The longer the line is, it still has the same slope. So if we take a second here to take a look at these, there are 6 total trig functions. We've described 3 of the 6. The other 3 are reciprocals of these. So if I wanted to look at the reciprocal of, let's say, cosine, 1 over cosine theta is defined to be secant of theta. And so the reciprocal there is, instead of being x over r, is r over x. And we would also denote this as being the hypotenuse over the adjacent. Next up is 1 over sine. 1 over sine is cosecant of theta. Cosecant of theta then is defined as being r over y and is hypotenuse over opposite. Next up is 1 over tangent. We define 1 over tangent theta to be the cotangent of theta, and it is x over y, or adjacent over opposite, excuse me. So these are the 6 trigonometric functions. So hopefully you recall these from trig, but we will be using most of these interchangeably throughout the rest of the semester, and so it's a good idea to go ahead and study up on these. A couple other things I want to look at. Because we are working with right triangles, then we have what are called the Pythagorean identities. Now, as the name might imply, the Pythagorean identities use the Pythagorean theorem as sort of a basis for their structure. If you look at the right triangle directly above here, so this triangle, Pythagorean identity says for that triangle that x squared plus y squared equals 1 squared, or just 1. But we also know that we have a description here for what x and y are in terms of theta. And so if we replace x and y in the Pythagorean theorem with cosine theta and sine theta, then what we wind up with is cosine squared theta plus sine squared theta is equal to 1. And so that is what's called the first Pythagorean identity. Alright, if I take this identity as is and I divide through by cosine squared, then you would have cosine squared over cosine squared, which is 1, plus sine squared divided by cosine squared. Well, sine divided by cosine over here is tangent of theta, so that would be tangent squared. And then if I had 1 divided by cosine squared, 1 over cosine is secant, so this would be secant squared theta. And similarly, so this is if I divide by cosine squared. And similarly, if I take this original one and I divide by secant squared, or excuse me, divide by sine squared. So if I divide this by sine squared, then I get cosine over sine, and cosine over sine is defined as cotangent. So this is cotangent squared. Sine squared divided by itself is 1, and 1 over sine is cosecant, so this would be cosecant squared theta. And so together, these 3 identities form the Pythagorean identities. That's typically what they're called. So let me just clean that up a little bit and box it so we can have a nice final picture here. So these are the 3 Pythagorean identities. Alright, there are some other identities that we're going to be using. You may or may not be familiar with these, and that's okay. Next up is what are called the half-angle identities. Now I'm not going to derive these, I'm simply going to state them for completion's sake. We will be using these though, so make sure that you are somewhat aware of them, and it might not be a half bad idea to go back and look up how they're derived. There are 2 of these. The first one is cosine squared. So if you have cosine squared, you can replace this with 1 plus cosine of twice the angle divided by 2. The reason it's called the half angle identity is because the angle you're looking at is half of the one you're going to be replacing it with. And the more important thing to note here is that it gives us a way of reducing powers of trig functions. So if you have something in terms of cosine squared, you can reduce it to just a single power of cosine. That's going to be important for us here in a little bit when we talk about the integrals involving powers of trig functions. All right. Similarly, you have a half-angle identity for sine, and it's sine squared is 1 minus cosine of 2 theta all over 2. And then the final sort of piece to this puzzle are the double angle identities. These are probably less important, although the sine double angle identity is used quite often. The first one is cosine. So cosine of 2 theta is cosine squared theta minus sine squared theta. And sine of 2 theta is 2 sine theta cosine theta. And so these are the double angle identities. Let me go ahead and box these up as well. And so altogether we have these 4 sets of identities. We have the basic trig identities, we have the Pythagorean identities, the half angle and the double angle, and those are basically going to form the foundation of most of the trig work that we'll do the rest of the semester. Alright, if you need to go back and review some of this material from trig, I encourage you to do so. But the next set of videos is going to cover how do we use this to do some integration. Alright, thank you for watching.